Today, we are building an autonomous trading workspace using a localized architecture designed to keep financial data within a private environment. We will construct this deployment on 4 distinct pillars: local hardware provisioning, advanced API intelligence, direct brokerage integration, and mandatory security compliance. Operating an AI in the financial markets introduces 2 immediate problems: ensuring your trading data remains sovereign, and preventing long-term operations from racking up unpredictable compute costs. This configuration addresses both. By completing this setup, you stop interacting with the market as a manual participant and start operating as the architect of a system that integrates local compute with live market execution. Step 1 is establishing our hardware foundation. For a localized deployment, we are using the Apple Mac Mini, powered by the M6 chip. To give our agent enough compute without starving the host operating system, we need to allocate specific resources to a new virtual environment. We will dedicate exactly 6 CPU cores and the dual 16-core neural engine to this workspace. This virtual environment requires virtual machine isolation. This is a digital quarantine, a security perimeter that ensures our autonomous agent can only act within defined boundaries. This architecture map illustrates the design. Global security consortia standards require multi-agent sandboxes to remain walled off from your core operating system, preventing unauthorized file access. To activate this, open your macOS virtualization settings, find your VM profile, and check strict isolation. Prioritizing local VM isolation before we introduce any intelligence turns raw computing power into a defensively hardened financial environment. Step 2 brings us to the intelligence layer, where we connect our isolated workspace to the Claude Sonnet 5 Enterprise API. Inside your Anthropic Developer Console, generate a new API key, copy the string, and provision it directly into your localized agent's environment variables. When deploying autonomous agents for continuous, long-horizon execution, token consumption accumulates over thousands of cycles. If the price per token fluctuates, your operating costs become unpredictable. This chart shows the solution. Anthropic finalized standard pricing for Claude Sonnet 5 Enterprise, ensuring your cost trajectory follows this flat, predictable line instead of an escalating curve. Rates are set at exactly $2 per million input tokens and $10 per million output. Relying on a locked token price makes continuous algorithmic market execution financially viable for independent operators. Step 3 moves us to the financial execution layer. We need to connect our intelligent agent to the Longbridge brokerage ecosystem. In your agent's dashboard, initiate the Longbridge integration. This requires a standard OAuth authorization process to securely link the AI workspace directly to your live trading account. Before we can trade, we must address the regulatory environment. The EU AI Act enforces Article 50 transparency requirements on all deployed interactive AI systems. This schematic demonstrates how our system complies. Inside the Longbridge Compliance tab, you must toggle on active machine-readable provenance metadata. This ensures every piece of algorithmic trading data is tagged with a digital metadata footprint before it exits your sandbox. Embedding this compliance metadata directly at the integration level insulates your entire deployment from sudden regulatory audits or platform blacklists. We are now ready for the final operational phase, issuing live commands to the newly integrated trading engine. In the prompt interface, type a command to initiate a multi-asset risk scan of your current portfolio. Next, add your secondary parameters. Instruct the agent to rebalance the portfolio to a target allocation of 60% equities and 40% clean energy ETFs. This flowchart visualizes how the Longbridge native engine processes that request. It parses your natural language prompt, splitting it into discrete API trade orders based on current latency, and routes them securely through your isolated VM. Replacing complex code syntax with precise natural language prompts allows for sophisticated portfolio rebalancing through conversation rather than manual calculations. Your isolated, fully integrated algorithmic trading agent is now successfully deployed and live in the market. By pairing the 2-nanometer processing power of local M6 hardware with the fixed-price intelligence of Claude Sonnet 5, you have built a resilient operational foundation. Because this system adheres to both global virtual machine security protocols and EU transparency standards, the setup remains legally and operationally viable for the long term. Executing at this level requires precise systems architecture, which now serves as the primary gateway to institutional-grade market participation.